Have you ever stopped to think about that one pill you might take in the morning and how in the world it manages to work all day long? Well, it's not magic. It's actually this tiny, brilliant piece of engineering. Today, we are going to pull back the curtain on the incredible science of rate-controlled drug delivery.
Okay, so first things first, we really need to get our heads around the problem that scientists were trying to fix. You see, before all this advanced stuff, taking your medicine was kind of like putting your body on a roller coaster. Just look at this graph. This spiky line here, that's what happens with a standard old school pill. You get this huge jolt of medication right after you take it. That sends you way up into what's called the toxic range, and that's often where you feel those nasty side effects. But then just as quickly, it all crashes down, and suddenly the medicine isn't even working anymore. It's a total roller coaster, and believe me, not a fun one. So you get stuck in this really frustrating cycle of peaks and valleys, right? You get a massive blast of the drug that's way too much, followed by a long period where it's not nearly enough, and your symptoms start coming right back. And that's exactly why you used to have to take pills maybe 3, 4 times a day, just trying to stay in that sweet spot where it's actually effective. So you can imagine scientists and engineers looked at this whole situation and thought, you know what, there has got to be a better way. So they set out to design a system that could finally get us off that roller coaster and deliver medicine in a much smarter, much more stable way. And this, right here, this is the dream. A perfectly straight line, cruising right in the middle of that therapeutic range. No crazy spikes, no sudden crashes, just a steady, constant stream of medicine doing exactly what it's supposed to do. This beautiful, flat line is the goal of what's called zero-order release. And that brings us to the official term for this whole concept, controlled release. Now, the keywords you really want to focus on here are predefined, predictable, and reproducible. This isn't just about making a pill last longer. Oh no, it's about making it release its medicine with the precision of a Swiss watch. Now, this is a really important distinction you might hear about. Think of sustained release as being kind of like an hourglass. Sure, it's slow, but the rate isn't perfectly even, right? Controlled release, on the other hand, is like a metronome, just taking out that medicine at a perfectly constant, predictable rate. And in medicine, that predictability, well, that's everything. So the big question is, how on earth do they pull this off? I mean, how do you build a tiny, predictable machine inside something small enough to swallow? Well, it turns out there are a couple of incredibly clever ways to do it. So the first major strategy works a lot like a preset timer. These are called diffusion-controlled systems. And the whole idea is that the drug moves out of the pill or a patch at a rate that's physically baked into its design. A nicotine patch is a perfect example of this. You can think of it like a tea bag for your skin. The medicine, the tea, is inside this reservoir, and a special membrane acts like the paper of the tea bag, letting that medicine seep out at a very specific and very slow rate. That membrane is the secret sauce. So how do they actually dial in the speed? Well, it's all about that membrane. A thicker membrane is like a thicker tea bag. It's going to slow things down. And if the drug molecule itself is kind of slippery and moves easily through it, that's going to speed things up. By perfectly engineering all these little factors, scientists can design a patch that lasts for a day, a week, or even longer. But what if you want something even smarter than a timer? Well, the next strategy is more like a motion-activated light. Instead of just running on a preset schedule, it's actually triggered by its environment, which in this case is your own body. Okay, this is absolutely genius. It's called an osmotic pump, and it works like a tiny water-powered piston. Here's how. Water from your body gets pulled into the pill through a special membrane. That creates pressure inside, which then pushes the medicine out through a teeny tiny laser-drilled hole. It's a self-powered, perfectly paced delivery system. Amazing, right? And the control mechanism here is just beautiful in its simplicity. The release rate is basically governed by how easily water can get through that membrane and how big the surface area is. By engineering those factors, you create this tiny, unstoppable pump that works at a constant rate using your own body's water as fuel. It is absolutely ingenious. Now, as amazing as this technology is, it's not perfect. Like any technology, it has its trade-offs. And to really get the full picture, we've got to look at both the advantages and, the potential drawbacks. So let's break it down. What are the big wins and what are the potential pitfalls of these high-tech pills? The pros are pretty obvious, and they're huge. First, we get rid of those peaks and valleys, which means a much steadier therapeutic effect. We only have to take the medicine once a day, which is so much more convenient and makes it way easier for people to actually stick to their treatment. And for really powerful drugs, this steady delivery provides a bigger margin of safety. But there are some downsides to think about. If the pill gets crushed or broken, for example, it could release all its medicine at once. That's a scary thing called dose dumping. These pills are also a lot more complex and expensive to make. And sometimes a pill that works perfectly in a lab test doesn't behave quite the same way inside a unique living person. So when you put it all together, what's the big takeaway? Well, controlled release technology is way more than just a convenience. It really represents a fundamental upgrade in the whole way we think about and use medicine. This quote really just nails it. It's all about taking the guesswork and the chaos out of medicine and turning it into a precision science. So here's the bottom line. This technology has allowed us to go from using medicine like a sledgehammer to using it like a scalpel. It's all about precision, it's about control, and it's about working smarter with our bodies, not just on them. And this all leads to a really fascinating final thought. If we've already mastered the pre-programmed pill, what's next? Could we create feedback-regulated systems? I mean, imagine a smart device that doesn't just release insulin on a schedule, but actually measures your blood sugar in real time and delivers the absolute perfect dose in response. The future of medicine is getting smarter every single day.